Hello, my fellow YouTubers. This is Roy back again. Quick couple-minute video. There's two main things that are driving me through this project here, and it's Walter Russell and my boy Tesla. And in this book here, it's called The Occult Ether Physics. It's Tesla's hidden space propulsion system and the conspiracy to conceal it. I got two different versions of this, and there is some good stuff in here in regards to the ether. And I think I just passed it. We're exploring the ether. Chapter 2, exploring the ether. So this way you guys can just get a quick page by snapshotting this. Talks about J.J. Thomson. Okay, it's a good little read. You'll be able to get some of the gist here. 1881. Okay. That's all you get on that one. So, great read. Get it if you don't have it. Not too expensive. All right. And then, of course, Mr. Walter Russell. And The Secret of Light is one of the books that I've received. Haven't had a chance to open it up, but we are talking about Walter Russell. And the double helix vortex, which is some papers that I had acquired. And those papers were written by James Clerk Maxwell. And James Clerk Maxwell is very important in this as well. And on the first page, we will talk about the double helix. I don't think I have the pages right there. All right, so more about the ether, very important stuff about the ether. Kepler's second law and orbital stability and magnetic levitation, the ether itself. I have a lot of pages mixed up, but this all covers pretty much the broad spectrum of what we have here. I don't know where I put that front page. That's a great page to see, you guys. Damn, stretch it out. Here it goes. This way you could snapshot this and read it later. It's called the double helix alignment, okay? And it talks a little about Lenz's law. It talks about stretching of the ether and how it has a tendency to tighten up. And the tension and the lines of force. It is some beautiful work here. So, what is this coil in the middle? This coil in the middle here is going to be my electromagnetic dioid. And what we're creating here is, this is just in the workings, but here is a smaller scale and a bigger scale. Each one has 8 points of reference. The plan is to turn them both the same direction and create a Russell-Olean vortex, and this here would be the bigger, outer, wider. It has 8 points, and this is smaller and faster and also has 8 points. There's going to be some twisting here in the magnetic field, but we'll get into that later. So for starters, let me just plug that in, and got your tachometer here, and let's just we'll get it going slowly. I have it on low, but this right here, these are north on the outside. This is the South Pole, and this is your North Pole, and these are norths also. This will get a driver just like this. They'll be synchronized, and the plan is to get these in a synchronous way. I don't want to. $1,200 RPMs. We ain't got nothing going there. We can go ahead and step up. Hear that? RPMs jumping up dramatically. And I can make some adjustments right here. I don't know what happened. That's short. All right, I got it up there. So basically, you get the gist of, once we get both of these moving, there's going to be a vortex happening, and we're going to be dealing with the ether and what we're putting out here. I'll get some magnetic film. We'll get into some of the research. My magnetic diode will be to where we put this in between these two turning. And we'll have an LED hooked up to it. And we'll be able to sneak in here in the middle and pick up, we'll have the light up, and we'll look at the load going in to fire these, and we'll check to see if there's any strain in there. And I'll first start off with doing some experiments with you guys to show you what the strain does. So volts coming in to the power coil on both of these wheels. I'll be able to show you and explain and demonstrate when I put an inductor around or near or close in proximity to these magnets, that there's a lens effect that's happening. And there's no free energy there. But the free energy would be between this little one and this bigger one when they're both turning, that this diode that I built will go in the middle, and none of these will even know that that's there, and that's where I tend on pulling energy. Now watch this. This is what I'm talking about, inductor. Now watch how I'm going to watch the RPMs. Look at that. It's like a electromagnetic brake. Okay. Like a brake. Just because I put an inductor near there, the lens effect appeared. And that's what we're dealing with. We're dealing with how saturation in this conductor is causing the lens effect to appear. This is not iron, this is aluminum. So this experiment will be the basis of showing you guys how to move away from the lens effect and bring in some other circuits. Now watch, I'll bring this back in. You can see the speeds up to 2500. All I'm going to do, drop it. Now if I bring it up just along the outside of it, so watch. Lens effects back. Look, it slows down. So I'm putting an opposing magnetic field on that wheel. And it's reacting to this conductor and causing a lens effect to appear. With that being said, we're going to work through this to be able to put Tesla's pancake coil in the middle. It's a coreless coil. We're going to get in the middle of that dipole, which goes in between that south and that north. Well, it's 12 minutes. I was only trying to be 3. Guys, leave your comments. Peace out.